Hello, this is question 9 on June 2018 paper 2 from AQA, and you have a market trader notices that daily sales are dependent on two variables, the number of hours T after the stall opens and the total sales X in pounds since the stall opened. The trader models the rate of sales as directly proportional to this. After 2 hours, the rate of sales is £72 per hour and total sales £336. And we have to show that we can write this differential equation. So what they are telling us is the rate of sales. The rate of sales is going to be dx by dt because x is the sales and rate of change is my derivative with respect to t. And they say it's proportional to that expression. So I have proportional to 8 minus t divided by x. And they are giving me here some details so I can find this constant. They say after 2 hours, so t is 2, because it's the number of hours after the stall opens. Rate of sales is 72, so dx by dt is 72. And the total sales, x, is 336. So what I'm going to do is to substitute everything in my expression and find k. So I have 72 is going to be k 8 minus 2 divided by 336. And from here, I get that k is 4032. Yeah? Which is going to give me this expression here. So I have the dx by dt is going to be 4032 times 8 minus t divided by x. And the only thing that they have done is this x that is dividing, they have put it here at the front. Yeah, so therefore I can say that x dx by dt is 4032 8 minus t. And that's the first part of the question. Then for the next one, it says hence, so I'm going to use that expression that I just found, show that x squared is this expression here. So what I'm going to do is use this expression. It's a differential equation, so I'm going to integrate to find an equation that relates x and t. Remember, when I have differential equation, I'm going to put all the x in one side and everything with t in the other side. So I'm going to integrate x dx equal to 4032 8 minus t dt. And I'm going to integrate this expression and this expression. I can write the constant inside or outside the integral. Integral of x squared x dx is x squared divided by 2. Then I have 4032. Integral of 8 is 8t. Integral of t is t squared divided by 2. And then I will have a constant of integration. I can, for example, to eliminate 2, because I don't have the 2, I can multiply everything by 2. So I have x squared here is 4032, and these 2 is multiplying the 8t, and then I can just cancel when I multiply by t. So I have 16t minus t squared plus c. They don't tell me anything in particular to find c, but I know when the stall is closed, so when t is 0, sales are 0. So I can say that when t is 0, x is 0. And that means that when t is 0, all this is 0, all this is 0, and x is 0, so c has to be 0. Yeah, so I have 0 equals 0 plus c, therefore c is 0. And I just have this expression here without the c. Yeah, so x squared is 4032, 16t minus t squared. And the next part says the stall opens at 9:30. The trader closes the stall when the rate of sales falls below £24 per hour. So when we have dx by dt below 24, yeah, or smaller or equal than 24. Using the results in parts A and B, calculate the earliest time that the trader closes the stall. A and B. So A is this differential equation, and B is the connection between X and T. So what we know is this is 24 when when the person closes the store. So what we have is that 24x is going to be this equation here, this expression here. So we have 24x is going to be 4032, 8 minus t. 4032, 8 minus t. But at the same time, I know that the connection between x and t is given by this equation. And even if you're not able to deduce this part, you can use it. So don't lose marks for not using the expression. So my expression is that x squared is 4032 t 16 minus t. And from these two, I need the time because I need to know when the person is closing the store. So between these two equations that are simultaneous equations with two unknowns, t and x, I'm going to eliminate x. And to eliminate x, I can, for example, make x the subject in the first one. So x is going to be 4032 divided by 24 is 168, multiplied by x minus t, and then I'm going to substitute in the other one, yeah? So I have x squared, 168, 8 minus t, all squared is going to be 4032 t 16 minus t. If I squared this bracket here, I have this one square and the bracket square. 168 square is 28,224, then 8 minus t squared, 4032. I'm going to expand the bracket with the t, so I have 16t minus t squared. And when I divide, I can divide everything by 4032 because I get a nice whole number, yeah? So this is 7, multiply 8 minus t squared is 16t minus t squared. I expand the brackets, so 64 minus 16t plus t squared is 16t minus t squared. I expand the other bracket, so I have 448 just multiplied by 7 minus 112t plus 7t squared. I reorganize my equation. So I have 7t squared plus 1t squared, 8t squared. Then minus 112t minus 16t is minus 128t. And this 448. I can divide everything by 8 to simplify a bit. So I have t squared minus 16t plus 56 equals 0. This is not easy to factorize, so we are going to use the quadratic formula. I could use the calculator straight away, but write the quadratic formula so you have some working out for that. Yeah, so we can say that t is going to be minus b, so 16 plus minus square root of b squared, 16 squared, minus 4 times 56 and 1 divided by 2a, which is 2. And from here you get a value of t that is just dividing because I need the actual number, and the other t is 10.828. This is the first time that the sales dropped to £24 per hour. This is the next time, but I need the first time because it's when they are closing the store. And they say calculate the earliest time then the trader closes. So we started at 9:30 and we need to add 5.17 hours. The way of doing this would be writing those hours. So 5.17 hours is going to be 5 hours, 0.17 hours. If we multiply this by 60, we have minutes. So this is 5 hours and 0.617 by 60 is 10.26. So I'm going to leave just 10 minutes rounded, yeah, to the nearest minute. So we need to close the stall 5 hours, 10 minutes after it opens. It opened at 9:30, so the time it closed I'm going to write here, time it closes is at 14:40, yeah, or 2:40 p.m. And that's all with this question. That's what they ask in this part, when it closes again, yeah, the earliest time, yeah. And that's all with this question.